Every generation of humans has wondered if we might someday live on another world, a place where we build cities beneath unfamiliar skies and turn alien landscapes into homes. The planet Mars has long been the most promising candidate, lying close enough to reach, familiar enough to imagine, and strange enough to inspire. From the first telescopes, astronomers saw channels, polar caps, and hints of rivers, fueling speculation that Mars might not be barren. And the idea of reshaping it into a living world, of terraforming, has captured imaginations for more than a century. Welcome to the Drowsy Astronaut. Here we drift deeper into the cosmos, while gently setting aside the troubles of your day so you can relax or even fall asleep while your subconscious wanders through the patient arc of terraforming. Not as fantasy alone, but as a measured study of what might be possible. So, let's begin. When we speak of terraforming Mars, we mean altering its climate, atmosphere, and surface, transforming it from a cold, dry, thin-aired desert into a place where humans might breathe without machines. The vision is audacious, for it means nothing less than turning a planet into a second Earth. But today, we must ask, is this reality within reach, or is it science fiction dressed as science fact? And the truth is that the answer lies at the intersection of physics, engineering, and imagination. Perhaps we should begin with what Mars actually is now, a planet roughly half the size of Earth, with a day just 40 minutes longer and seasons that echo our own but colder and harsher. Its surface is painted in rust-red iron oxide, stretching into plains, valleys, and extinct volcanoes taller than any mountain on Earth. The air above it is thin, just 1% the density of Earth's atmosphere, composed mostly of carbon dioxide, and the temperature averages far below freezing, with polar caps made of water ice and frozen carbon dioxide. Even gravity itself is weaker, only about 38% of Earth's pull, making every step lighter, every jump higher. The sky above glows not blue, but salmon orange, tinted by dust that drifts endlessly across its plains. Mars has moons too, Phobos and Deimos, irregular potato-shaped rocks that circle quickly overhead, and the world is both familiar and alien, promising survival yet reminding us constantly of danger. So why do we dream of transforming it, of wrapping Mars in seas, forests, and skies like our own? The answer is partly survival. Humanity must one day expand beyond Earth if we are to endure cosmic timescales. It is also curiosity, the restless urge to push into the unknown, to test whether we can carry life where it has never been. And the goal of terraforming is the boldest expression of that desire. Every plan for terraforming Mars begins with atmosphere, for without thicker air, water cannot flow and humans cannot breathe. The challenge is enormous. We would need to warm the planet, release gases, and create pressure nearly 100 times greater than today's. At first, this seems impossible, like asking to lift an entire world with human hands, and the obstacles are both technical and physical. Mars is small, cold, and far from the sun. When we think of how to warm it, one suggestion is to release greenhouse gases, the same process that warms Earth unintentionally through climate change. The irony is striking. What threatens us here might save us there. By trapping more heat, Mars could be coaxed into melting its polar caps, releasing water and carbon dioxide. And the feedback could thicken the atmosphere, beginning a cycle of warming. Perhaps orbital mirrors could help. Vast sheets of reflective material floating in space, concentrating sunlight onto the surface. These mirrors could nudge temperatures upward, melting ice, triggering chemical releases. Another option might be giant factories that pump fluorine-based gases into the sky, far stronger than carbon dioxide at holding heat. And the vision is that human industry itself could become planetary engineering. Even nuclear devices have been proposed, detonated above the poles to release frozen carbon dioxide quickly, jump-starting a greenhouse effect. The idea is dramatic, controversial and dangerous, yet it speaks to the desperation of scale required. Terraforming is not a gentle project. It is an act of raw force against planetary inertia, and the question is whether humanity should wield such power over a world. So far, estimates vary widely. Some say we could thicken the atmosphere in centuries. Others insist it would take millennia. The truth is that no model is perfect. Mars is complex, and small changes cascade unpredictably. Still, scientists believe certain thresholds exist. If we could raise pressure enough, water could flow, skies could hold clouds, and life could begin. And the possibility remains tantalizing, though distant. Every discussion of terraforming must also consider magnetism, for Earth's magnetic field shields us from solar winds, preventing our atmosphere from being stripped. Mars once had such a field, billions of years ago, but it cooled and its core solidified, leaving the planet exposed. Without protection, any atmosphere we build could be slowly eroded by the sun's particles. And the solution may require artificial magnetic shields, orbiting generators that recreate what nature lost. When we imagine walking on Mars after terraforming, we picture oceans filling the low basins. Valles Marineris as a water-filled canyon, the northern plains as shallow seas. The air would thicken, skies might turn blue, winds would carry clouds, and rain would fall. Forests could grow, perhaps engineered plants first, then ecosystems layered over time, and the vision of a second Earth would stand realized. Even then, gravity would remain low. Muscles would adapt, bones might weaken without constant exercise. The biology of humans and animals might shift over generations, creating Mars-born descendants with different physiologies. Terraforming does not change gravity, only climate and air. And the truth is that such differences would shape culture as much as science. Perhaps the greatest challenge is not physics, but ethics. Should we remake a world that may already harbour life? If microbes exist beneath Martian soil, would terraforming destroy them? Are we colonizers imposing Earth's image upon a world that has its own history? And the debate is ongoing: survival versus preservation, ambition versus respect. Every proposal forces us to weigh cost too. Terraforming would take trillions of dollars, centuries of commitment, and technologies we do not yet have. The resources required are staggering. Entire industries dedicated not to nations, but to a planet. Some argue this money should be spent on Earth, solving climate, poverty, disease. And the tension between Earth first and Mars first divides visionaries and pragmatists. When we step back, we see the scope of the dream: a planet reshaped by human hands, skies rewritten, seas reborn. The concept belongs partly to science fiction and partly to science itself. Mars stands as a mirror, reflecting both our ambitions and our limitations. And the story of terraforming begins not with answers, but with questions. Even now, we launch probes and rovers to measure, to sample, to imagine what is possible. The rover's curiosity and perseverance crawl across rust-red plains, drilling into rock, hunting for water and life. Orbiters map ice beneath the surface, reveal minerals, track dust storms, and the information they bring is the foundation upon which terraforming dreams may rest. So, the story rests tonight not with certainty, but with vision. the outline of what terraforming Mars could mean and the scale of what it would require. The details remain complex, the timelines immense, the obstacles vast. But still, the human spirit pushes forward, daring to imagine Mars not as a red desert, but as a blue and green world reborn. The first step in any realistic path to terraforming Mars is warming the planet, because before air thickens, before seas return, and before plants can grow, the surface must climb out of its deep freeze. Temperature is the master key. Without it, carbon dioxide remains locked in ice, water remains frozen solid, and all human engineering collapses under cold too intense to sustain life. Raising that temperature even by a few degrees could set off a chain reaction, a feedback loop where each gain amplifies the next, slowly tipping Mars into a more Earth-like state. And the question becomes, how do we provide the spark that lights this planetary fire? Every idea centers on sunlight, greenhouse gases, or artificial heat sources, because no single approach alone is powerful enough. The sun already delivers energy to Mars, but at only half the strength Earth enjoys, it is not enough to warm the surface naturally. So, scientists imagine ways to catch more of that sunlight, to hold it longer, and to amplify its warmth. And the methods they design range from practical industry to sheer science fiction. Perhaps the most straightforward plan is to use greenhouse gases, releasing carbon dioxide, methane, or exotic fluorine-based compounds into the Martian sky. These molecules act like invisible blankets, letting sunlight in while holding heat from escaping. If enough of them gather, the polar caps would begin to melt, releasing more trapped gas and reinforcing the warming. And the possibility exists that this feedback could push Mars past a tipping point where change sustains itself. When we consider this carefully, however, obstacles quickly appear. For Mars may not hold as much accessible carbon dioxide as once believed. The caps contain some, but studies suggest the total reservoir may be too small to thicken the atmosphere significantly. Even if all of it were released, Mars might still fall short of the needed pressure to hold liquid water. And the conclusion from many researchers is sobering. Greenhouse gases alone may not be enough. So attention turns to more exotic options, gases so strong that even tiny amounts can heat the planet. The candidates include fluorocarbons, molecules that do not exist naturally but can be manufactured. These compounds trap heat thousands of times more effectively than carbon dioxide, making them efficient planetary warmers. But the challenge lies in scale. Entire global industries would need to operate on Mars, producing these gases for centuries. Even nuclear solutions have been proposed, dramatic and controversial in equal measure. The idea is to detonate devices above the poles, releasing heat and sublimating frozen carbon dioxide directly into the atmosphere. This would jumpstart a greenhouse effect, forcing Mars to warm far more rapidly than slow methods allow. Yet the risks are immense. Radiation, global fallout, and the possibility of destabilizing rather than stabilizing the planet. Perhaps the most elegant ideas come from orbital engineering, placing giant mirrors in space to direct more sunlight onto Mars. These mirrors could hover at stable gravitational points, reflecting constant beams onto the poles. Even a slight increase in solar input would warm the surface, melt ice, and release gases. And the vision of glittering artificial suns orbiting Mars carries both beauty and ambition. Every one of these proposals asks for immense energy and resources, raising the question of where they would come from. The factories needed to produce gases would require power, raw materials, and human oversight. If mirrors are built, they must be launched from Earth or constructed in orbit, a feat of engineering unlike any attempted before. and the time needed for such projects would stretch across centuries. When advocates are pressed, they argue that even small steps could matter, that we need not terraform Mars overnight, but instead begin with partial measures. The goal would not be immediate Earth-like air, but enough pressure to allow water to flow and reduce the burden on human habitats. In this scenario, terraforming is not a single leap, but a slow layering of advances. And the idea is that each generation would inherit progress, moving a little closer to the dream. Even if Mars remains unbreathable for centuries, humans might live more easily with intermediate steps. The pressure could be raised to a point where suits are simpler, masks are lighter, and crops can grow under plastic domes. Water could flow in canals or reservoirs, drawn from melted ice and preserved in artificial lakes. And the progress of each stage would make the next more possible. Perhaps this incremental approach is not failure, but wisdom, for planets change slowly, and we must respect their pace. Mars cannot be bullied into Earth's twin in decades, but it can be nudged patiently, coaxed rather than forced. In doing so, humanity would learn lessons about climate, balance, and responsibility. And the irony is clear. To change another planet, we must first learn to understand our own. Every engineer who sketches plans for Mars also thinks about Earth, because the tools of terraforming are the same as those of climate control. The gases that warm one world are the same that endanger ours. Orbital mirrors imagined for Mars could also shade regions of Earth in crisis, and the technologies developed for Mars may prove vital here long before they shape the red planet. When we examine the numbers, the scale grows daunting. The energy needed to warm Mars is staggering, equivalent to centuries of global industry. The calculations reveal just how much mass must be moved, how many gigatons of gas must be released. It seems impossible at first glance, beyond the reach of our species today. But the history of humanity shows that impossible goals sometimes become inevitable with time. Even in the 21st century, our reach into space grows quickly. Rovers crawl, satellites map, rockets land and return. The infrastructure that begins with exploration may one day expand into settlement. Factories could eventually operate on Mars itself, mining rock, splitting ice, generating power. And the line between science fiction and science fact shifts slowly outward. Perhaps the truest beginning of terraforming is not technical at all, but psychological. The choice to believe that Mars can be altered. The decision to invest centuries of effort into one world is unlike any project humanity has ever attempted. It requires patience beyond politics, vision beyond lifetimes, and cooperation beyond nations. And the faith that sustains such work may be as important as the physics. Every detail of warming Mars reminds us how fragile Earth is by comparison. For here, the right balance of gases, fields, and cycles already exists. The planet we live on provides the template, the rare alignment that makes oceans flow and forests breathe. In altering Mars, we measure what makes Earth unique, what invisible balances allow it to thrive, and the lesson may help us defend Earth more carefully than before. When the atmosphere begins to thicken, the transformation would accelerate, rivers carving channels, storms forming, air turning hazy with clouds. The sight of rain on Mars would be the first undeniable sign that the impossible was becoming real. Every drop would carry more than water. It would carry meaning, proof that humans can extend life's reach, and the moment would mark a turning point in the history of our species. Even with progress, obstacles would remain. Radiation from the sun would still threaten without a magnetic shield. The surface would still be toxic in places, filled with perchlorate harmful to biology. Gravity would still be weak, raising questions about health over lifetimes. And the truth is that Mars can be made habitable, but never identical to Earth. Perhaps that is the point, not to clone Earth, but to create something new. The world that emerges from terraforming would be a hybrid, Earth-shaped in design, Mars-shaped in origin. Its culture would be different, its ecosystems engineered, its skies tinted differently. And the descendants who live there would call it home in ways we cannot yet imagine. Every vision of Mars reshaped carries a mirror for ourselves. For in imagining what we might build, we also imagine who we might become. The ambition is both noble and dangerous, a test of responsibility as much as ability. Terraforming shows us our capacity to reach, but also tempts us to overreach, and the balance we strike will shape not only Mars, but the legacy of humanity. When the first lakes shimmer under a foreign sun, when forests root in imported soil, when air is drawn without masks, humanity will have crossed into a new era. The moment will not erase our struggles on Earth, but it will remind us that we are not trapped here forever. We carry within us the potential to spread life where it has never been. And the destiny of that potential lies waiting, rust-red, beneath a salmon sky. Even now, the idea is no longer confined to fiction. Governments, companies, and thinkers sketch the first outlines of possible steps. The plans are tentative, small compared to the vastness of the task, but they mark the beginning. It may take centuries, but beginnings always do. And the whisper of possibility is enough to set us moving. The moment Mars begins to warm, another question follows immediately. Where will the water come from, and how will it move across the surface? Every living system we know depends on water, not only as a drink, but as the medium for chemistry, the solvent for life. Mars holds water now, but hidden, stored as ice in the polar caps and buried under dust in frozen slabs. And the task is to unlock it, to make it flow again after billions of years locked away. When the air pressure rises and the surface warms, frozen water will start to shift, ice will sublimate, trickle, and seep into valleys. The lowlands of Mars, especially the vast northern plains, could fill with shallow seas if enough ice melts. Valleys like Valles Marineris could flood, carving inland seas that stretch hundreds of kilometers. And the vision of blue water under a salmon sky becomes the first image of a habitable Mars. Perhaps we should remember, however, that water is not evenly distributed. Much of it may remain locked in deep permafrost. The challenge is not only to melt it, but to manage it, to prevent it from vanishing into the thin air as vapor. Even with a thicker atmosphere, Mars may lose water quickly if it escapes upward into space, and the magnetic shield idea returns again, a guardian not only for air, but for seas. So, humans may need to supplement Mars with imported water, at least in the early centuries. The asteroid belt nearby offers candidates, icy bodies that could be nudged into Martian orbit. By harvesting their ice, we could deliver rivers of new water directly to Mars. And the image of redirected comets streaking into the Martian sky is both inspiring and frightening. Every plan for water leads naturally to soil, for water without soil is only half the story. The ground of Mars is dry, dusty, and filled with salts, particularly perchlorates that are toxic to life. If plants are to grow, the soil must be treated, washed, or engineered into something fertile, and the work of soil making may take as long as atmosphere building. When we imagine the first farms on Mars, They will not be in open fields, but in greenhouses, domes sealed and warmed, with soil imported or manufactured. The plants will be pioneers, chosen for resilience, bred to survive thin air and strange light. Microbes will come too, breaking down toxins, fixing nitrogen, building fertility grain by grain. And the process of turning sterile dust into soil is the hidden backbone of terraforming. Even as air grows and water flows, soil will resist, for true ecosystems need time to weave. The microbes that build fertility do not work quickly, they move with patience measured in centuries. Mars may need generations of human-guided ecosystems before it can sustain itself. And the truth is that every blade of grass may carry behind it 1,000 experiments. Perhaps then, we should think of terraforming as gardening on the scale of a world. The gardener knows not only how to plant, but how to wait, how to nurture, how to adapt when seasons fail. Humans on Mars will become gardeners of valleys, tending not just crops, but entire climates. And the act of cultivation will be both technical and poetic, a dialogue with a world that resists and responds. Soil also matters because it holds memory. In its chemistry lie the signatures of Mars's past. The rocks remember floods, droughts, volcanic eruptions, and the long freeze. By studying them, we glimpse what Mars once was and what it might become. And the lessons of that history will guide how we coax life back into the present. Every image of terraforming eventually arrives at ecosystems, forests, lakes, rivers, animals, but ecosystems are delicate. They require balances we barely understand even on Earth, and the risk of collapsing them on Mars is enormous if we rush. When ecosystems begin, they will be simple: hardy plants, engineered microbes, perhaps algae seeded into shallow lakes. The first goal will be to increase oxygen and stabilize soil, not to provide food. As decades pass, more species could be introduced, climbing slowly toward complexity. And the dream is of a self-sustaining cycle that no longer needs constant intervention. Even then, Mars will never be identical to Earth. Its gravity will shape biology differently. Its skies will filter light in unfamiliar ways. The plants might grow taller under weaker pull, or differently colored under altered sunlight. Animals could adapt too, bodies evolving into lighter, stranger forms. And the life of Mars will be new life, not copied Earth, but cousin to it. Perhaps humans themselves will adapt in parallel, becoming Martians in physiology and culture. The descendants of settlers may walk differently, breathe differently, even think differently as their environment shapes them. Language may evolve too, words borrowed from Earth reshaped by a new world. And the identity of Mars-born humans will be tied not to what was imported, but to what grew there. So water, soil, and ecosystems are not separate. They are stages of a single unfolding. The sequence must be respected, for no tree can stand without soil, no soil without microbes, no microbes without water. Terraforming moves at the pace of this chain, no faster. And the understanding of that pace will be the difference between success and collapse. Every step reminds us that we are not just builders, but stewards. The act of remaking a planet is as much responsibility as it is achievement. We cannot force Earth's template onto Mars without care. And the lesson is that patience and humility are as vital as rockets and factories. When the first Martian rains fall, they may feed nothing but dust at first, but slowly, dust will darken into mud, mud into soil, soil into fields. The image of the first grass on Mars, fragile and green against red dust, may one day stand as powerful as the first step on the moon. That moment will be the proof that Mars is no longer sterile, but a host. and the meaning will echo not just in science, but in culture and spirit. Even as we imagine it, doubts remain. Is this wise? Is this right? Is this sustainable? The questions are heavy, but they sharpen rather than diminish the dream. Mars asks us to decide what kind of species we want to be. And the answer lies not in declarations, but in the quiet persistence of effort. Perhaps this is why terraforming feels so profound. It is not only about physics and engineering, but about destiny. The destiny of life is to spread, to reach, to adapt. Mars waits as the nearest field, barren but fertile for imagination. And the story of its transformation is the story of our courage to extend life. The dream of Mars reshaped always turns to air, because no matter how much water flows or how many seeds we plant, humans cannot live without breathing. Every attempt to terraform must eventually ask, how do we thicken the atmosphere and enrich it with oxygen? The task is immense, for today the Martian sky is not only thin, but poor in what we need, and the goal is not simply warmth, but breath. When we measure the current atmosphere of Mars, we find it is mostly carbon dioxide, 95% of it, in fact, with barely a trace of oxygen. The pressure is less than 1% of Earth's, so low that liquid water quickly boils away. Even if it were thicker, the composition would still be wrong, choking instead of sustaining. And the problem is that Mars must be changed in both quantity and quality. Perhaps the first stage is simply pressure, thickening the air until lungs can fill it all. The goal of this stage is not yet to make it breathable, but to make it protective, to allow water to stay liquid, to shield from radiation, and to hold warmth. Factories would churn carbon dioxide and other gases skyward, building a buffer of air, and the result would be a world where masks still exist, but domes and suits grow simpler. So, we speak then of oxygen, the rarest ingredient in the current Martian sky. The presence of oxygen is what truly marks a world as living, for it does not linger unless life replenishes it. Earth has oxygen only because plants and microbes release it constantly. And the lesson is clear. If we want oxygen on Mars, we must build the same cycle. Every possible path begins with photosynthesis, either natural or artificial. The simplest idea is to seed algae and hardy plants in controlled environments, letting them churn carbon dioxide into oxygen over decades. If scaled massively, this could slowly enrich the sky. And the vision of algae green lakes under a pink horizon becomes a symbol of transition. When we calculate how long this would take, the timescales stretch beyond centuries, for to fill an entire planet's sky requires unimaginable amounts of oxygen. The numbers are daunting. Trillions of tons must be produced, sustained, and balanced. Algae alone cannot manage it quickly, though they may lay the foundation. And the truth is that shortcuts will be sought. Perhaps chemical engineering could speed the process, splitting water into hydrogen and oxygen with vast networks of machines. The hydrogen could be vented away or used as fuel, while the oxygen is released skyward. Massive solar or nuclear-powered plants could line valleys, exhaling life into the thin air. And the dream is that industry itself becomes a breathing machine for a planet. Even more exotic possibilities have been suggested. Bioengineered organisms designed to thrive in Martian soil, releasing oxygen far faster than Earth plants ever could. These creations would be living tools designed to function not in one field, but across a planet. Their roots might reach deep into dust, breaking down salts, fixing nitrogen, and exhaling oxygen. And the debate around such organisms would be as much ethical as technical. So, the idea of oxygen stretches into philosophy as well as science. The air we breathe on Earth is not only a chemical mix, but a record of life's long presence. To add oxygen to Mars is not only to change a planet, but to declare it alive in a new way. And the weight of that declaration is enormous. Every attempt to make Mars breathable must also consider fire. For oxygen does not simply support life, it fuels combustion. The balance of gases must be precise. Too little oxygen and we suffocate, too much and every spark becomes catastrophic. Earth holds at 21% oxygen, a sweet spot of safety and vitality, and the challenge of Mars is to reach that balance across an entire planet. When engineers design domes and habitats for the near term, they often begin by adjusting air only within them, a microcosm of what terraforming attempts on the global scale. These bubbles of pressure and oxygen act as test beds, showing what is possible. From these, data accumulates: how soils behave, how microbes adapt, how oxygen cycles sustain. And the knowledge will one day scale outward, from domes to valleys, from valleys to planets. Perhaps the greatest irony is that the same gases we fear on Earth may be required on Mars. The greenhouse effect that drives climate change here is the very lever of hope there. On Earth, we fight to slow carbon dioxide. On Mars, we may manufacture it. And the contrast reminds us how delicate the balance is, how different the same molecule can be in two contexts. Even if the atmosphere thickens, it cannot simply stay put forever. Mars has no magnetic field, and solar winds strip air away. So the solution must be not only creation, but protection. Without shields of some kind, the work of centuries could vanish grain by grain, and the necessity of an artificial magnetosphere becomes undeniable. So, scientists propose vast generators placed between Mars and the Sun, magnetic arcs that deflect solar particles before they hit. The scale of such engineering is staggering. Planetary defense built as deliberately as a city, it would not only shield atmosphere, but radiation, making the surface safer for life. And the day such a shield activates may be remembered as the true start of Mars's rebirth. Every discussion of atmosphere also stirs the question of whether we should aim for full Earth conditions or settle for less. The argument is practical. Perhaps Mars need not be fully breathable, only close enough to ease life. Masks could provide the last step, letting the planet carry most of the burden, and the compromise may prove the difference between possible and impossible. When we weigh these paths, the cultural impact looms as large as the technical. The idea of a sky that humans can breathe has power beyond science. It marks a transition in imagination. Mars as a world where humans belong, not as visitors, but as residents. And the moment a child inhales Martian air without a mask will carry weight across history. Perhaps then the air itself is the true symbol of terraforming, more than oceans, more than soil. The act of breathing is so constant, so unnoticed, that to make it possible on Mars would rewrite the ordinary. Every breath would be a reminder of the work of centuries, and the ordinary would become extraordinary again. Even now, experiments on Earth test fragments of these ideas. Sealed biospheres, algae reactors, engineered microbes. The lessons are clear. Systems must be closed, balanced, and sustainable, or they collapse. In space, closed systems already exist aboard stations, recycling air and water endlessly, and the technology of spacecraft becomes the seed of planetary atmospheres. So, the problem of air is not one we face in theory alone. We live it already in orbit, on every mission, in every dome we plan. The principles of recycling, balance, and protection are known, even if scaling them to planets remains daunting. Terraforming demands that we take those principles and amplify them to planetary scale. And the path from spacecraft cabin to Martian valley is clearer than we first imagine. Every time we breathe on Earth, we do not think of it as a gift, but as background. The project of Mars terraforming forces us to see it as achievement, as something earned. It asks us to measure the invisible, to build what Earth gave freely. And the meaning of that shift may change how we see Earth itself. When the day comes the air holds steady on Mars, the sound of wind will be different, carrying weight, carrying life. The hiss of oxygen through leaves, the whisper of storms across plains will mark a new age. And in those sounds, humanity will hear its own expansion. The air will no longer be borrowed, but given. The moment a world begins to hold air, the potential for water changes instantly. Vapors linger longer, ice melts faster, clouds can gather and release their burden. Every step of terraforming until now has been about unlocking the possibility of flow, of turning hidden reserves into movement. Mars waits quietly for that transformation, its valleys etched with scars of ancient floods, its basins shaped by forgotten seas. And the task before humanity is not only to release water, but to guide it, to teach it to cycle again. When we speak of water cycles, we mean more than liquid flowing on the ground. We mean clouds that rise, winds that carry, rains that fall, rivers that carve. The cycle is what keeps Earth alive, a circulation of renewal that feeds soil, fills lakes, and nourishes life. On Mars, this cycle is broken, a frozen archive paused for eons in stillness. And the goal is to restart it, to bring rhythm back to silence. Perhaps the first rains will not come gently. They may be storms, sudden downpours as air thickens and heat grows uneven. The surface may flash flood, channels filling too quickly, soil failing to hold water at first. In time, though, balance will emerge, rains spreading, lakes stabilizing, snow falling at higher altitudes, and the dream is of a hydrological engine humming once more. So much depends on atmosphere, for without pressure, water flees upward as vapor instead of falling as rain. The air must thicken enough to hold drops intact, to allow clouds to grow heavy. If oxygen and nitrogen grow with carbon dioxide, the sky will slowly find equilibrium, and the sight of rain streaking a pink horizon will mark the first successful breath of a cycle. Every drop of water will matter at first, for soil is poor and greedy, drinking quickly into dust. The salts of Mars, particularly perch laurets, will make much water toxic at the start. But water also heals soil, washing, leaching, diluting poisons grain by grain. And the years will see dirt soften into fields that can host roots. When rivers run again, they will follow the maps left long ago. Dried deltas, braided channels, and great canyons waiting to be carved anew. The largest is Valles Marineris, a rift so vast it dwarfs Earth's Grand Canyon. Water here could form an inland sea, shimmering under thin blue skies, and the sight of waves lapping in a canyon 3,000 kilometers long would symbolize transformation. Perhaps the northern plains will hold the greatest seas, vast lowlands where water naturally pools. The basins here are like waiting bowls, etched by past oceans billions of years ago. Filling them could create seas the size of Earth's Mediterranean, stabilizing climate further. And the presence of such water would change the albedo of Mars, reflecting sunlight, altering heat. So, the water cycle is not only hydrology, but climate. Oceans act as regulators, storing warmth, releasing it slowly, smoothing seasons. The oceans of Earth are why climate is stable enough for life. Without them, swings of temperature would be brutal, as on Mars today. And the plan of building seas is as much about stability as beauty. Every new climate system will have to be managed, for unlike Earth, Mars may not hold balance naturally. The smallness of the planet means its climate is more fragile, more easily tipped into chaos. Storms already sweep its surface, dust lifting high into the thin air, circling the globe. And the fear is that water cycles could amplify storms in ways we do not predict. When rain and dust meet, the interplay may be complex: mudslides, flash floods, and choked skies. The dynamics of Martian weather will not mirror Earth perfectly, so scientists must model carefully, build tools to monitor and adjust cycles in real time, and the work of climate control may be never-ending. Perhaps technology will become part of the cycle itself, machines seeded alongside rivers, managing flows, reducing floods. Artificial lakes may act as buffers, storing water in calm reservoirs. Some proposals even imagine geoengineering tools, clouds seeded with particulates, storms nudged by orbital reflectors, and the line between nature and machine will blur on a terraformed Mars. So far we have imagined water as surface flow, but subsurface aquifers may hold even more potential. The ground hides ice beneath dust, layered in strata across the planet. If warmed, these aquifers could feed springs, artesian flows, hidden rivers, and the emergence of underground water could be both resource and risk, shaping land in sudden collapses. Every ecosystem we hope to build depends on regularity, on cycles that repeat without interruption. The trees we plant will need not only soil but predictable rains. The animals we bring will depend on steady rivers and ponds, and the balance of life will collapse if cycles fail too often. When balance begins, Mars may host climates of variety: deserts in some regions, wetlands in others, highland snows feeding valley streams. The diversity of climate will be essential, for ecosystems thrive on variation, not uniformity. In this way, Mars could echo Earth's complexity, though tuned to its own conditions, and the result would be a mosaic world, half familiar, half alien. Perhaps we should think of climate not as finished, but as ongoing art. The brushstrokes are gases, oceans, and sunlight, layered across centuries. Mars becomes a canvas for humanity, not painted in haste, but over lifetimes. And the masterpiece is not control, but balance. Even as seas form, ice caps may remain, smaller than today, but persistent. The caps will shift, retreating in warm ages, growing in cool. In time, Mars may find rhythms of its own, cycles like Earth's ice ages, and the dance between ice and sea will mark geological epochs. So far we have asked what humans might do, but water itself has agency. It cuts valleys, builds deltas, weaves wetlands. The shapes of Mars will be carved anew, guided by the physics of flow. Tectonics sleep, but erosion and sediment will still redraw maps, and the geography of a living Mars will slowly diverge from the frozen maps we know. Every generation will see a slightly different planet, new lakes where none were before, rivers lengthening, climates stabilizing. The children of early settlers will inherit a Mars greener than their parents saw. Their grandchildren will take for granted rains their ancestors never imagined, and the memory of barren Mars will fade into history books. When the first storms bring thunder, the psychological shift may be immense. The sound of weather is the sound of a living world. The rumble of distant thunder across Martian valleys will echo differently in the thin air, but powerfully in the minds of humans. For us, storms are ordinary, but on Mars they will be miracles. And the moment lightning flashes over red rock will be unforgettable. Perhaps animals will follow last, long after microbes and plants. The oxygen levels must rise first, and ecosystems must be stable. But eventually, insects, birds, and mammals could be carried across, and the sight of a bird gliding in Martian skies will prove life has truly spread. Even then, adaptation will be constant. Mars will never be Earth. The seasons may stay harsher, the days dustier, the skies stranger. But life does not need Earth's perfection to thrive, only opportunity. And the meaning of terraforming is to grant that opportunity. So, humanity will not just terraform Mars, but Mars will terraform humanity, shaping our culture, our values, our patience. The presence of water and climate cycles sets the stage, but no world is habitable without air that can be breathed. Every calculation of Mars's future eventually returns to this, the composition of its atmosphere. Mars offers thin air mostly of carbon dioxide, heavy enough to trap heat but deadly to lungs. And the path from this to oxygen-rich skies is long, uncertain, and vital. When we think of oxygen, we must remember that on Earth it is not natural in the beginning. It is the byproduct of life itself. The first atmosphere of Earth was toxic, choked with gases from volcanoes, barren of breath. Only microbes, tiny cyanobacteria in ancient seas, began releasing oxygen billions of years ago. And the air we breathe today is the slow accumulation of their patient work. Perhaps then the solution for Mars is the same, to seed life, even in its simplest forms, as the engine of change. The idea is to create photosynthetic networks, lakes of algae, farms of engineered microbes, vast domes that breathe as factories do. These systems would inhale carbon dioxide and exhale oxygen grain by grain, and the ambition is to do in centuries what Earth required eons to complete. So, we picture green lakes under a salmon sky, their surfaces rippling in thin winds, their waters rich with living cells. The algae spread within them are pioneers, toughened by engineering, able to endure radiation and perch laureates. As they grow, each cell adds a molecule of oxygen to the air above, and the sky begins, molecule by molecule, to change. Every plan that depends on biology must face scale. The sheer mass of oxygen needed is astronomical. The atmosphere of Earth contains over 1 trillion tons of oxygen. Mars would require similar volumes to sustain unmasked humans, and the time frame is stretched, perhaps centuries or longer, before the air itself can host us safely. When humanity dreams of shortcuts, machines again appear as the option. Reactors that split water, releasing oxygen by force. Electrolysis plants, powered by solar or nuclear energy, could work night and day. The hydrogen released could be vented away or burned for fuel, leaving pure oxygen behind. And the vision of industry turning lakes into sky remains powerful. Perhaps the most ambitious idea is to combine biology and industry, letting each do what it does best. The factories would provide the initial surge, enriching air enough to make open lakes stable. The microbes then multiply, feeding on the carbon dioxide, producing more oxygen naturally, and the synergy of machine and life would become the great engine of change. Even with these efforts, humans would need to adapt life forms themselves, plants that do not exist today. The crops we rely on here are fragile. They expect thick air, stable warmth, and nitrogen-rich soil. On Mars, we would need pioneers, genetically designed trees and grasses that can thrive under thin skies. And the introduction of these organisms would reshape not only the land, but our science. So it plays its part in oxygen as well, for microbes within it breathe and exhale as much as forests above. The soil of Mars is sterile for now, but microbes can make it living. With time, a balance of respiration and photosynthesis could stabilize, and the ground itself would become a partner in making air. Every atmospheric model also includes nitrogen, an overlooked but essential ingredient. The air of Earth is mostly nitrogen, a buffer that prevents oxygen from burning too fiercely. Without enough nitrogen, Mars could not hold a stable balance. Its fire's too dangerous, its breathing too thin. And the search for nitrogen reserves on Mars is as crucial as water or carbon dioxide. When Mars lacks, imports may be necessary. Icy asteroids rich in nitrogen could be diverted. The delivery of such resources is daunting but not impossible over centuries. Each impact or harvested body would bring with it the invisible cushion that life requires, and the addition of nitrogen would temper oxygen, making it safe. Perhaps the greatest challenge is patience, for even with every tool, oxygen rises slowly. The sky will not turn blue in decades, nor will domes vanish overnight. Generations will live under glass, farming, breathing, surviving while the outside world matures, and the hope passed down will sustain them as much as technology. So, we imagine milestones along the way. The first time oxygen reaches 1%, the first flame that burns in open air, the first plants that can stand outdoors unsealed. The ceremonies of these milestones will echo like lunar landings. Children will grow up with each marker, proud to inherit a sky that breathes more easily than before. And the line between sealed domes and free valleys will blur gradually. Every historical parallel reminds us this has been done before, not by us, but by life itself. The great oxidation event on Earth was the first planetary terraforming, driven by microbes. Mars may host a second, this time with humans as shepherds. And the poetry of repeating that cosmic story is not lost. When oxygen begins to accumulate, the sound of Mars will change as much as its look. Wind will grow deeper, storms more resonant, echoes more human. The voices of settlers will carry farther. Footsteps will crunch differently, sound itself reshaped by thicker air. As atmosphere builds, the familiar emerges. Not Earth, but something closer. And the psychology of that familiarity may matter more than chemistry. Perhaps we should pause here and ask, is breathable air the goal, or merely easier air? The argument for partial terraforming is strong. Air thick enough to hold warmth and water, but not yet safe to inhale unassisted. With masks, life could proceed while waiting for oxygen to build. And the balance between ambition and pragmatism will guide decisions. Even with patience, dangers linger. High oxygen means fire. Thin oxygen means suffocation. The management of atmosphere is not a one-time act, but a continuous vigilance. Sensors must monitor, industries adjust, biology respond. And the lesson of Earth's fragile balance must not be forgotten. So, much of this depends not only on tools, but on vision. Do we see Mars as a second Earth or as something different? The answer shapes how much oxygen we seek, how close to home we wish to bring it. Mars may thrive with less, a compromise between what humans want and what Mars can give. And the truth is that compromise will define the project. Every narrative of Mars asks us to imagine the first unmasked breath, the moment when lungs fill not with recycled air but with sky itself, will stand as one of history's greatest thresholds. It will not come quickly, nor without risk, nor without generations of waiting, but the symbol of that breath will travel farther than Mars itself. When future humans read of the early centuries, they will know this was the hardest stage, harder than warming, harder than water. The making of air is invisible, thankless, slow. Yet nothing is more transformative, nothing more essential. And the quiet labour of billions of microbes and machines will be the unseen epic of terraforming. Perhaps this long struggle is necessary to teach humility, to remind us that even with power, nature sets the pace. The oxygen of Earth is not a gift easily replicated, but a lesson learned across eons. By attempting to create it, we measure our limits, our patience, our resolve, and the reward is not only air, but wisdom. Even now, prototypes exist. Algae farms in Antarctica, sealed ecosystems in deserts, oxygen-generating machines on Mars itself. The MOXIE experiment aboard Perseverance has already proven carbon dioxide can be split into oxygen. Though small, this machine points the way, a seed of future factories. And the fact that oxygen has already been made on Mars is a quiet triumph. So, the path is clear, even if the distance is long. Machines, microbes, and patience woven together to alter a sky. The story of oxygen is not glamorous, but it is the core of everything. Once breath is possible, even partially, Mars is no longer foreign, and the sense of belonging begins to grow. The moment air begins to thicken and water begins to flow, another threshold arrives, the introduction of life beyond microbes. Every ecosystem on Earth is layered, from bacteria and fungi to plants and animals, each depending on the others in an invisible web. Mars offers nothing of that yet, only sterile dust, thin skies, and silence. And the challenge is to build that web from the ground upward, slowly, deliberately, and with care. When we picture the first green on Mars, it will not be forests, but pioneers, hardy mosses, lichens, and engineered plants built for survival more than beauty. These organisms excel at colonization, able to live on bare rock, to cling to surfaces, to turn minerals into nutrients. As they spread, they stabilize soil, reduce erosion, and begin the slow work of fertility. And the vision is of valleys dusted with faint green, a color unseen on Mars for billions of years. Perhaps domes will host the earliest forests, sealed from the outside, rich with thick oxygen, glowing with artificial suns. Inside these domes will grow experimental ecosystems, miniature Earths in alien soil. From these testbeds, lessons will come: which plants thrive, which fail, which combinations balance best, and the knowledge gained will prepare the leap to open landscapes. So, the introduction of forests into open Martian air will come only when oxygen levels rise. Not enough for humans, perhaps, but enough for plants to anchor and breathe. The first trees might be engineered to withstand thin oxygen and cold nights, hybrids designed for endurance. As they grow, their roots deepen, their leaves feed oxygen to the sky, their bodies fix carbon into soil. And the growth of these forests would accelerate the transformation itself. Every tree is more than wood and leaf. It is a machine for air and water, a slow pump of climate. The roots pull moisture, the trunks hold it, the leaves release it as vapor. With forests, humidity rises, clouds gather, rains return more predictably, and the cycle tightens into a rhythm that echoes Earth. When grasses and shrubs follow trees, diversity blooms, fields sway, undergrowth spreads, soils enrich. The plants attract insects if they are introduced, pollinators to carry reproduction forward. Those insects become food for other species, each layer feeding the next. And the cascade of ecology begins to build momentum. Perhaps animals will be added cautiously, one species at a time, tested in valleys before spreading. The smallest come first. Hardy insects, engineered microbes, simple grazers. As systems stabilize, larger creatures might follow, birds, amphibians, even mammals. And the result would be ecosystems with complexity, resilience, and beauty. Even then, caution must remain, for ecosystems collapse easily if one part grows too fast. The balance must be tuned with humans as caretakers and gardeners on the scale of continents. If predators are introduced too early, prey species vanish. If prey multiply unchecked, land is stripped bare, and the patience of centuries must guide every addition. So, what kind of forests would Mars host? Earth's replicas or alien cousins? The choice may lean toward engineered species, not copies, but plants tailored for Martian air and soil. They could have thicker leaves to resist radiation, deeper roots to chase water, altered chlorophyll to use different light, and the forests of Mars would be familiar and strange at once. Every valley could take on a different identity, shaped by design as much as nature. The lowlands might hold wetlands and lakes, rich in reeds and algae. The slopes of canyons could host forests, their walls shielding them from wind, and the uplands might remain tundra-like, sparse with hardy shrubs. When diversity grows, the carbon cycle strengthens. Plants lock carbon in wood, microbes bury it in soil, water carries it into sediments. The planet slowly builds its own regulators, no longer needing constant human correction. At that point, ecosystems begin to sustain themselves, carrying forward even without constant intervention. And the dream becomes reality, a world alive in its own right. Perhaps culture will grow as much as biology, for humans will weave meaning into these forests. The first tree planted outdoors may be remembered like a monument, a marker of history. Songs may be written about rains, festivals held when new species arrive, and the identity of Martian culture will entwine with its growing biospheres. Even the sound of forests will reshape human psychology on Mars. The whisper of leaves, the rustle of grasses, the hum of insects. The silence that defined Mars for so long will be broken not by machines, but by life. This music of ecology will soothe, comfort, and inspire settlers, and the world itself will begin to feel like home. Soils enriched by roots will release nitrogen and oxygen more steadily, balancing air further. The feedback between plants and atmosphere strengthens with each generation of growth. As oxygen rises, more species thrive, accelerating the process in a spiral upward. And the sky deepens in color, reflecting thicker air. Every ecosystem also means death as much as life, for cycles depend on decay. The bacteria that decompose plants recycle nutrients, closing loops. Without them, forests choke on their own waste, soils exhaust, balance collapses, and the humble decomposer becomes as essential as the towering tree. When Mars hosts complex cycles, its seasons will shift into new patterns. Rains in spring, dry winds in summer, snows at highlands in winter. The planet will write its own climate music, different from Earth's, but patterned, predictable. Settlers will learn its cues, when to plant, when to harvest, when to prepare for storms, and the knowledge of Martian weather will evolve into tradition. Perhaps cities will cluster around rivers and lakes, where forests grow thick and oxygen is richest. The settlements may blur into their ecosystems, not sealed domes, but open-air towns under alien skies. Children there will grow never knowing barren Mars, only this hybrid green world. And the contrast between their home and the frozen deserts outside may fade in memory. Even so, parts of Mars may remain untamed, deserts untouched, dust storms still sweeping. The decision may be made to leave some regions wild as preserves of original Mars. Such choices will reflect respect, a reminder of what was lost and what was gained, and the ethics of planetary gardening will remain with us always. So, biospheres will not be uniform, but patchworks, oases of growth amid expanses still barren. The spread will be uneven, ecosystems expanding from strongholds outward. In time, forests and plains will cover more, deserts shrinking but persisting, and the planet will wear its transformation as a mosaic, not a blanket. Every generation will see progress faster than the last because living systems compound. Each forest seeds another, each river feeds more valleys. The exponential growth of ecology will accelerate like population once did on Earth. Small beginnings in scattered domes will ripple into continental ecosystems, and the centuries will bear witness to a planet awakening. When animals arrive, their presence will change more than biology. Birds carrying seeds farther, mammals grazing and fertilizing, predators maintaining balance. The introduction of each species will ripple through cycles unpredictably. Some will thrive, some fail, some reshape systems in ways no one planned. And the adaptation of each will create new Martian ecologies. Perhaps Mars will surprise us with emergent patterns, ecosystems that evolve uniquely. The mix of Earth species, engineered hybrids, and Martian conditions may yield outcomes we cannot model. Forests might grow in unexpected zones, wetlands in unlikely basins, and the identity of Martian nature will be its own, not Earth's copy. Even the aesthetics will matter. The color of leaves, the hue of skies, the look of rivers under smaller suns. The light of Mars is weaker, redder, filtering through dust, so plants may look darker or stranger. The appearance of a Martian forest may be haunting, beautiful, unfamiliar, and the wonder of walking through one will redefine what we call natural. So, the building of biospheres is not a step, but a symphony. Air, soil, water, microbes, plants, animals, humans, all tuned together. The success of this symphony depends not on dominance, but on harmony. If any part overplays, the music falters. If all balance, it endures. And the lesson is that terraforming is less conquest than composition. The moment Mars begins to hold forests, rivers, and breathable air, the conversation shifts from survival to civilization. Every previous stage of terraforming was about physics, chemistry, and biology, but now the human story rises to the surface. Mars becomes not just a place where life can exist, but a place where life can flourish. And the question is no longer whether humans can live there, but what kind of civilization they will build. When settlers first arrive, their world will still be fragile. Domes scattered across valleys, farms under glass, and greenhouses lit by artificial suns. The daily life of these pioneers will be structured around maintenance, monitoring air, repairing machines, rationing resources. As terraforming progresses, their routines will shift toward farming, building, and eventually governing. And the pattern of Martian life will slowly diverge from the patterns of Earth. Perhaps the first Martian communities will be small, intimate, and deeply cooperative. The need for survival in harsh conditions will force collaboration, making every member of society vital. In time, as stability grows, diversity of roles will expand. Teachers, artists, musicians, leaders, and the culture that emerges will reflect both necessity and creativity. So much of identity will be shaped by environment, weaker gravity, thinner air, red horizons. The children born on Mars will grow up with lighter bones, taller frames, and different physiologies than their Earth-born ancestors. They will adapt naturally to the planet's pull, moving differently, seeing differently under a smaller sun. And the word Martian will come to mean something biological as well as cultural. Every society shapes its myths around origins, and Martians will too. The stories told to children may not be of Earth's oceans or forests, but of the first rains on Mars, the first tree planted outdoors. They will learn of ancestors who carried water through dust storms, who coaxed soil into life, who breathed musks until the air grew rich, and the myth of Martian beginnings will unite them across generations. When we think of politics, we must ask, will Mars govern itself or remain tied to Earth? The distance makes direct control difficult, with signals delayed by minutes across the void. At first, Earth nations or corporations may hold sway, funding and directing settlements, but the moment independence becomes possible, Mars will likely demand it. Perhaps governance will begin in councils of settlers, chosen for skill rather than heritage. The leaders of early Mars may be engineers, biologists, and farmers, not politicians. In later generations, as populations rise, governance may grow formal, parliaments, laws, constitutions, and the character of Martian democracy or autocracy will depend on the challenges they face. Even economies will diverge, for resources and trade will shape culture as much as politics. The wealth of Mars may not lie in gold or oil, but in water, metals, and data. Some argue that Mars could become a hub of mining, exporting resources back to Earth. But the truth may be that Mars will export ideas, technologies, culture, philosophy born of alien soil. So education will matter more than ever, for each generation must inherit not only survival skills, but planetary stewardship. The students of Mars will learn geology not as distant science, but as daily knowledge. They will study ecosystems not as theories, but as gardens outside their windows. And the wisdom of planetary balance will become part of their ordinary schooling. Every city will grow in unique ways shaped by geography, climate, and history. The settlements in the northern seas will rely on fishing and algae farming. Those in canyons may build tiered communities carved into walls like ancient cliff dwellings. And the architecture of Mars will be unlike Earth's, adapted to thinner skies and lighter gravity. When buildings rise taller than any on Earth, it will be gravity that makes them possible. The structures of Mars can soar, supported by weaker pull, safe against quakes. Towers may reach into clouds, greenhouses stacked hundreds of meters high. And the aesthetic of Martian cities will blend utility and wonder. Perhaps art will emerge early, born of the need to find beauty in survival. The painters of Mars may use rust-red dust as pigment, capturing skies no Earth canvas could hold. Musicians will compose in domes, where echoes sound strange under thin air. And the poets will write of horizons twice as far, of stars sharper against salmon skies. Even religion may adapt as humans seek meaning in new contexts. The faiths of Earth will travel, carried in memory and ritual. But new beliefs may form too, shaped by the frontier, the fragility of air, the miracle of rain. And the sacred spaces of Mars may be forests, rivers, or even the first shield generators. So relationships between Earth and Mars will always carry tension. The dependency of early centuries will foster resentment and gratitude in equal measure. Earth will see Mars as its child, but children grow, demand independence, redefine themselves. And the moment Mars asserts full sovereignty may be turbulent. Every cultural artifact will matter more in early years, for traditions are seeds of continuity. The holidays of Mars may not celebrate harvest moons or spring blossoms, but the anniversary of the first rain, the first breath of unmasked air. As these rituals spread, they will bind communities into something distinctly Martian, and the heritage of Mars will be written in new calendars, new legends. When literature emerges, it will reflect isolation, endurance, and vision. The novels of Mars will not be romances of cities alone, but epics of landscapes, storms, and survival. Their writers will craft stories of exile and belonging, of dust and green, and the voice of Martian art will echo across centuries. Perhaps conflict will come, as it always does, between groups, ideologies, or nations. The causes may be resources, governance, or independence. Wars may be rare, but disagreements inevitable, shaped by distance and scarcity. And the hope is that Mars will learn from Earth's mistakes. Even leisure will evolve differently. Sports shaped by lighter gravity, games played across valleys. The athletes of Mars may leap farther, climb higher, endure longer. Children will invent games Earth children cannot imagine, running through dust plains, swimming in shallow seas. And the joy of play will mark Mars as a home, not just a project. So identity forms slowly, Martian by birth, by adaptation, by culture. The people of Mars will speak differently, move differently, dream differently. They will measure time in sols, not days, in Martian seasons, not Earth's. And the lineage of Martians will diverge into something wholly new. Every civilization needs symbols, and Mars will craft its own. The flag may bear rust red, sea blue, and forest green, marking the stages of transformation. Its anthem may recall silence turned to song, dust turned to life, and the symbols will unify Martians in ways practical governance cannot. When Earth looks back at Mars, it will see more than a colony. It will see a mirror of itself, filtered through distance and necessity. The pride of humanity will swell, but so too will questions. Has Mars surpassed us or repeated us? If wars are avoided, if balance is kept, Mars may become the wiser sibling, and the legacy of its civilization will teach Earth as much as Earth taught Mars. The rise of Martian civilization cannot occur without technology, for no other project in human history will demand such constant engineering. Every advance that makes Mars survivable must be multiplied, scaled, and sustained across generations. At first, technology will simply be about survival: domes, life support, power grids. But the vision is much larger, reaching toward infrastructure that can support millions, not hundreds. When we speak of energy on Mars, the sun is weaker and dust storms common, so reliance on solar alone may falter. The need for nuclear power becomes immediate, compact reactors humming within settlements. Over time, larger systems may emerge: fusion plants, geothermal stations, orbital solar farms. And the pulse of this energy will drive every other transformation. Perhaps the most striking infrastructure will be the magnetic shield, the invisible guardian of atmosphere. The idea is to place a vast generator at the Mars-Sun L1 point, deflecting solar wind. This structure would not resemble a machine so much as an artificial force of nature. And the day it activates will mark the beginning of permanent atmosphere retention. So ill itself may be transformed through technological intervention. Microbes seeded deliberately, chemical treatments spread across plains. The machines that plow Martian ground will be as much laboratories as tractors. They will analyze salts, break down toxins, engineer fertility in real time. And the partnership between biology and machinery will redefine agriculture. Every city will rely on transport systems built for thin air and low gravity. The vehicles may glide with magnetic levitation, riding along tracks laid across canyons. Air travel will look different, not dense airplanes, but hybrid gliders, rockets, and airships, and the sensation of moving across Mars will feel alien compared to Earth. When orbital infrastructure grows, Mars will no longer be isolated. Stations circling above will act as hubs, factories, and gateways. The docks of these stations will host ships arriving from Earth, cargo unloading and departing. Over time, Mars may build its own fleet, vessels designed in Martian shipyards, and the presence of those fleets will extend its reach into the solar system. Perhaps communication will shape culture as much as transport, for distance cannot be erased. The delay between Earth and Mars ranges from minutes to nearly half an hour. This gap prevents live conversation, forcing reliance on messages and asynchronous communication. And the psychology of this delay will shape identity, emphasizing independence. Even education and knowledge sharing must adapt to the distance. The libraries of Mars will need to be self-sufficient, holding archives of Earth's science and culture. Updates will arrive in waves, not streams, changing the rhythm of intellectual life. And the teachers of Mars will pass on both Earth's heritage and their own. So trade becomes more symbolic than practical, at least in the beginning. The cost of transporting bulk goods across millions of kilometers is staggering. Mars may export rare isotopes, manufactured technologies, or knowledge instead of raw materials, and the flow of goods will reflect necessity rather than abundance. Every tool of industry must be designed for self-replication because shipping spare parts from Earth will be impossible. The factories on Mars must produce not only machines, but the machines that make machines. This recursive industry is the foundation of independence, and the moment Mars achieves full self-repair will be another marker of maturity. When human populations swell, cities will sprawl beneath protective domes or carve into rock. The infrastructure of air and water circulation will rival Earth's power grids in complexity. Pipes will carry oxygen like rivers, controlled by centralized networks, and the safety of millions will depend on flawless operation. Perhaps orbital mirrors will still hover, catching sunlight, directing it onto valleys and seas. These giants of space engineering may shimmer like artificial stars in Martian skies. Settlers might name them, write songs of their light, see them as constant guardians, and the awe they inspire will blend science with poetry. Even within infrastructure, culture seeps in, architecture reflecting identity. The design of Martian buildings may fuse Earth memories with new aesthetics. Homes might be rounded against pressure stress, layered with glass for sky views. And the look of Martian skylines will be instantly recognizable. So long as technology endures, Mars will grow more confident. But failure in one system could still cascade into disaster. The redundancy of every structure will matter. Backups for air, water, power. Each settlement will resemble a spacecraft, though spread across landscapes. And the discipline of vigilance will never fade completely. Every relationship between Earth and Mars will depend on infrastructure of communication and travel. The ships that bridge the two worlds will remain lifelines, even as independence grows. They carry people, memories, and culture across months of void. And the bond between planets will never vanish fully. When Mars looks outward, its ambitions may not stop at survival. The moment a planet can engineer its own air, seas, and forests, it can also reach further. Mars could serve as the springboard for asteroid colonies, Jovian moons, even Saturn's icy worlds. and the tools forged for terraforming may carry humanity deeper still. Perhaps this is the greater meaning of Mars, not only as a second home, but as a teacher for the stars. The lessons learned in engineering a planet will apply across the galaxy. If we can turn a barren desert into a cradle of life, no world will seem unreachable, and the confidence born of Mars may echo far beyond the solar system. Even if Mars never fully breathes like Earth, it may still thrive, half-domed, half-wild. The civilization there may not need perfection to endure. People will live, love, create, and govern under salmon skies. And the continuity of life across worlds will matter more than the details. So infrastructure is not only pipes, wires, and machines. It is the skeleton of a civilization's identity. The bridges between domes, the tunnels carved into cliffs, the towers rising into clouds all reflect values. They speak of cooperation, vision, endurance. And the future of Mars will be written as much in steel and glass as in forests and seas. The moment humans imagine reshaping Mars, the question of ethics rises quietly behind the machinery. Every proposal for mirrors, factories, or engineered microbes carries more than engineering. It carries philosophy. Mars is not only rock and dust, but a place with history, geology, and perhaps a hidden record of life. And the question becomes, what right do we have to change it? When we speak of ethics, the first dilemma is simple. If Mars once hosted life, even microbes, should we disturb or preserve it? The discovery of even a single Martian microbe would change priorities overnight. Terraforming might threaten that life, overwhelming it with imported biology, and the debate would split between protection and transformation. Perhaps some argue that Mars has waited too long and that its silence grants permission. The planet is barren now, its rivers dry, its sky too thin. By reshaping it, humanity gives it back what was lost: warmth, water, air. And the argument is that we are restoring, not erasing. So, others counter that we may destroy something irreplaceable, the only second origin of life ever found. The principle of planetary protection says we should not contaminate what is unique. If life evolved twice in one solar system, it proves the universe teems with biology, and the loss of that record would be immeasurable. Every stage of terraforming forces balance: survival of humanity, preservation of science, respect for worlds. The line between stewardship and conquest is thin. If we rush, we may repeat Earth's mistakes. Short-term gains, long-term losses, and the lesson must be humility, even in ambition. When philosophers weigh in, they ask whether planets have rights of their own. The idea seems strange, to grant dignity to rocks and skies. Yet some argue that planets hold intrinsic value as cosmic entities untouched by us, and the decision to alter them should not be taken lightly. Perhaps the greatest paradox is that humans must change Mars to survive, yet must hesitate in doing so. The species cannot live long-term without air and water, but hesitation may delay survival even as it honors ethics, and the balance between urgency and caution will define our legacy. Even beyond Mars, this dilemma expands to every world we may reach. The act of terraforming is a template. How we behave on the first world may echo across the galaxy. Do we arrive as conquerors or as gardeners? And the answer will reflect in every future colony. So ethics becomes not a side note, but the central thread of terraforming. The choice of methods, timing, and pace reflects values as much as science. We could blast the poles with nuclear fire, or we could coax lakes into existence slowly. And the difference is not only in results, but in philosophy. Every civilization reveals itself in how it treats its environment. The Earth shows us this clearly in forests cut, oceans overfished, air polluted. Terraforming may be a second chance, a cosmic rehearsal to do better. And the question is whether we will learn or repeat. When we imagine future Martians, they may not see terraforming as destruction at all. They may see it as their birthright, their origin story. The debates of early centuries may fade into myth. By their time, forests, lakes, and skies will simply be home, and the memory of barren Mars will feel as distant as Earth's primordial seas feel to us. Perhaps this is the deeper layer of ethics, not only what we choose, but what we bequeath. The children of Mars will live with the consequences of decisions they never made. We owe them care, foresight, and humility in the choices of today, and the responsibility of terraforming extends across centuries. Even the concept of ownership shifts in this context. The question arises, who owns a planet? Nations, corporations, or all humanity? If Mars is transformed, does it belong to settlers, to Earth, or to life itself? And the answer will test our definitions of property and commons. So history may repeat, colonies demanding independence, corporations demanding profits, nations demanding influence. The danger is that Mars becomes another site of human conflict rather than unity, but terraforming also offers the chance to transcend this pattern, and the opportunity lies in seeing Mars as heritage, not territory. Every ethical puzzle is sharpened by scale. This is not a forest or a river, but a world. The power to alter it carries weight unlike any past action. If we fail, the cost is not only technological, but moral, and the consequence will echo across how humanity sees itself. When Mars finally hosts life again, whether imported or native, the moral picture grows even more complex. The presence of multiple ecosystems, Earthborn and Martian-born, raises questions of coexistence. Do we allow them to mix, or do we preserve them separately? And the outcome may decide the survival of one or both. Perhaps the best metaphor is gardening, not conquest. The gardener reshapes a plot, but with care, respect, and patience. They prune, water, guide, but do not dominate without thought. And the ideal of terraforming is to become planetary gardeners. Even the language we use matters: conquest or cultivation, exploitation or stewardship. The words shape how we think and how we justify actions. If terraforming is framed as conquest, violence follows. If the metaphor is cultivation, patience follows. So philosophy flows not apart from engineering, but alongside it. The decisions of gas production, shield construction, and genetic design are ethical as well as practical. What kind of Mars we build depends on what kind of species we wish to be, and the mirror of our choices reflects back onto Earth. Every discussion of destiny must circle back to Earth itself. The planet that gave us oceans, forests, and breath is fragile, endangered by our own hand. Terraforming Mars may succeed technically, but if Earth collapses, the lesson is hollow. And the truth is that saving Earth must parallel shaping Mars. When we step back, the philosophical question becomes cosmic. Are we meant to stay on one world or to spread across many? The universe seems vast enough to welcome expansion. But purpose is not given, it is chosen, and the story of terraforming is the story of our choice to spread life. Perhaps then, Mars is not only about survival, but about meaning. The act of remaking a planet is a statement that life matters, that life deserves to continue. It says that even in a universe of silence, we choose song, and the weight of that statement is profound. Even in doubt, we may find guidance in awe. The feeling of standing beneath stars, of realizing our smallness, humbles us. If awe accompanies ambition, destruction may be avoided, and the balance of humility and vision may carry us through. So, ethics and philosophy will never leave the Martian project. They will shape every law, every invention, every dream. The debate is endless but essential, and the civilization that emerges on Mars will embody the answers even if unspoken, for the destiny of terraforming is not only to change Mars but to change us. The future of Mars stretches far beyond the centuries it will take to terraform. It extends into millennia, into epochs, into eras where new civilizations will inherit what we leave behind. Every stage of Mars's transformation until now has been imagined in human timescales, centuries at most. But Mars itself will continue to evolve long after our immediate plans end. And the questions we ask today must include the distant tomorrow. When? The first forests take root, their seeds will not stop after a few generations. They will spread, adapt, and diversify across thousands of years. The plants we introduce may evolve into new forms, altered by gravity, air, and light. Animals, too, will adapt, their physiology bending to weaker pull, thinner skies, different cycles. And the descendants of these life forms may become as native to Mars as Earth's species are to our home. Perhaps humans will evolve alongside them, shaped by Martian conditions across generations. The bones of Martian-born children may grow taller, their muscles lighter, their frames more delicate. Their lungs may become more efficient, their blood carrying oxygen differently. And the identity of Martians will one day be biological as much as cultural. So, the long future of Mars is not only a story of engineering, but of evolution. The process of life adapting to Mars will never end, for planets and organisms shape one another endlessly. Earth itself was remade by microbes that exhaled oxygen, by plants that spread forests, by animals that grazed and hunted. And the same interplay will occur on Mars, though with humans as conscious participants. Every system we build must consider stability, for nothing remains unchanged. The atmosphere we thicken could thin again if magnetic shields fail. The oceans we fill could freeze or evaporate if greenhouse balances shift. And the resilience of Mars depends on constant maintenance across ages. When civilizations rise, they often fall, and the danger is that Mars could regress if humanity falters. The machines that pump gases, recycle air, or regulate cycles could fall silent. Without stewards, the planet might drift back towards sterility. And the lesson is that resilience must be built into the system itself, not dependent on one culture alone. Perhaps future humans will seed Mars with self-sustaining tools, bioengineered forests that adapt automatically, microbes that replenish soil endlessly, machines designed to last millennia. The goal will not be constant maintenance, but autonomous stability. So that, even if human civilizations ebb and flow, Mars remains alive. And the continuity of life will be secure beyond politics or collapse. Even with stability, change is inevitable, because climates shift naturally over millions of years. The tilt of Mars's axis wobbles more than Earth's, driving dramatic swings of ice and heat. Over ages, seas may retreat and advance, forests may wax and wane, and the future Martians will adapt to cycles as Earthlings once adapted to ice ages. So, Mars becomes not a static achievement, but a living experiment in planetary resilience. The systems built there will be monitored, adjusted, repaired, and reinvented across time. Each generation will inherit not only air and water, but responsibility, and the thread of stewardship will stretch endlessly into the future. Every civilization eventually asks, what lies beyond its horizon? The Martians of the future may look outward as Earthlings once did. They may see their terraformed world not as the end, but as the beginning, and the ambition of interstellar travel may grow naturally from their success. When a people have turned one planet green, the leap to others feels less impossible. The confidence of survival, of patience, of engineering becomes cultural memory. Mars could serve as humanity's rehearsal for the stars, and the legacy of its transformation may be measured less in trees than in journeys. Perhaps the same techniques, mirrors, microbes, shields, could apply to icy moons, distant exoplanets, or rogue worlds. The knowledge gained on Mars becomes a template, a manual for planetary rebirth. Carried with humanity across light years, it becomes our greatest export, and the gift of life extends further than we can yet imagine. Even so, Mars may remain special, the first transformed, the closest, the most familiar. The sentiment tied to it will be deeper than any future colony. No other world will carry the memory of first transformation, and the story of Mars will be recited wherever humans travel. So, the destiny of Mars is double: to host its own civilization and to prepare humanity for others. The civilization that grows there may one day be older than Earth's, outlasting us if catastrophe strikes. If Earth falls, Mars may preserve the flame of knowledge and life, and the weight of that possibility makes its project sacred. Every dream of Mars is also a meditation on mortality. The species we are today is fragile, confined to one planet, vulnerable to chance. Terraforming Mars does not remove that fragility, but it diversifies it, and the act of spreading makes extinction less likely. When historians of the future look back, they may see Mars as the fulcrum, the pivot point when humanity became interplanetary. The timeline of our species will divide. Before Mars, confined; after Mars, expansive. That transition will matter more than any single invention, and the symbol of Mars will grow larger with time. Perhaps, then, the real measure of success is not whether Mars becomes Earth-like, but whether it becomes a stable home. The criteria for that success may be simple: generations born, raised, and buried there. If millions live entire lives under Martian skies, the project is complete, and the proof of belonging will be written in lineage, not atmosphere. Even if Mars never fully matches Earth, it may still host thriving civilizations. The gravity may remain low, the skies thin, the soils salty, yet humans have always thrived in extremes, deserts, tundras, mountains, and the adaptability of life is its greatest tool. So, Mars's long-term evolution is not a quest for perfection, but for persistence. The continuation of cycles, the endurance of ecosystems, the growth of culture, these define success. Perfection may never arrive, but sufficiency will. And the meaning of Mars lies in sufficiency carried forward. Every echo of this story leads outward to stars, for once we know we can change one world, others call us. The galaxy is filled with barren planets, frozen moons, fiery rocks. With knowledge, we may see not deserts, but gardens waiting, and the possibility of endless life spreads before us. When future Martians launch ships outward, they will not see themselves as pioneers, but as continuers. The tradition of transformation will be their heritage. From their perspective, it will be ordinary, as natural as planting crops. And the ordinary will be extraordinary to us, but routine to them. Perhaps even Earth will be remade in response, inspired by Mars. The reminder of what can be done elsewhere may renew our stewardship at home. If we can heal deserts on Mars, why not deserts on Earth? And the cycle of learning flows both directions. Even as Mars matures, it will remain a symbol of fragility and hope. The world was once silent, cold, and lifeless, yet became green. It teaches us that no situation is hopeless, that patience can reshape the impossible, and the lesson of Mars will echo wherever we go. So, the far future of Mars is not only technological, not only biological, but spiritual. The idea of turning silence to song, of turning emptiness to fullness, reshapes human meaning. Civilizations will tell the story of Mars as parable, myth, and history, and the thread of life continues through it all. The story of Mars begins as silence, yet ends as symphony. A world once barren, now filled with forests, seas, and skies alive with life. Every step that brought us here was gradual, uncertain, stitched together by patience and generations of work. Mars now holds its own winds, its own rains, its own balance of ecosystems. And the moment has arrived when it is no longer a project, but a world in its own right. When humanity walks unmasked under Martian skies, the symbolism will ripple through history. It will mark the moment we became a species of two planets. The event will be remembered alongside fire, agriculture, and flight. We will look upward not as prisoners of one cradle, but as wanderers with more than one home. And the meaning of this expansion will extend beyond utility into identity. Perhaps the greatest triumph will not be in machines or domes, but in the ordinariness of daily life. The sight of children running beneath thin clouds, of elders tending gardens by Martian lakes, will matter more than reactors or shields. Civilization will thrive not through extraordinary events, but through ordinary days repeated across centuries. And the miracle will be how quickly the extraordinary becomes ordinary. So, the relationship between Earth and Mars will mature into something more than dependency. The exchange of knowledge, culture, and people will bind the two planets as siblings, distinct but connected. Mars will send innovations born of its challenges, while Earth sends traditions born of its depth. And the bond between them will evolve into cooperation, rivalry, and mutual growth. Every child born on Mars will carry a heritage unlike any before. The language they speak may diverge subtly from Earth's, molded by distance, time, and culture. Their stories will be written in Martian metaphors, not oceans and rivers, but dust storms and canyons. And the identity of being Martian will become as natural as being Earthling once was. When millions live on Mars, its politics will crystallize into independence. The planet will govern itself, shape its own destiny, write its own laws. The arguments of who owns Mars will fade into history, replaced by Martians owning themselves. Earth may resist at first, but distance and reality will enforce autonomy, and the independence of Mars will mark a new chapter in human civilization. Perhaps the culture of Mars will be more cautious, shaped by fragility and stewardship. The habit of balancing air, water, and soil may breed philosophies of responsibility. Unlike Earth, where abundance sometimes invited carelessness, Mars will teach humility. And the values of Martian society may influence humanity far beyond one world. Even religion may shift as Mars inspires new ways of seeing. The sacred may be tied to first rains, to forests grown under alien suns, to the act of survival itself. Faith will not vanish, but adapt, weaving ancient traditions into Martian experiences. And the spiritual meaning of terraforming may resonate for millennia. So, art will flourish, capturing the strangeness and beauty of a world reborn. The paintings may glow with hues Earth cannot know, skies of salmon and seas of emerald. Music might echo differently under thinner air, songs shaped by the acoustics of domes and valleys. And the aesthetic of Mars will emerge as a voice distinct from Earth's chorus. Every civilization eventually asks not only how to survive, but why. The Martians of the future will ask what role their world plays in humanity's greater story. Mars could remain a second home, content in its own stability. Or the ambition of its people may drive exploration outward, deeper into the solar system. When Martians look outward, the moons of Jupiter and Saturn may call to them, icy worlds rich with oceans beneath crusts, waiting for exploration. The experience of making Mars habitable will embolden them to attempt more. Terraforming will no longer be fantasy, but cultural memory, and the confidence gained will ripple outward across the solar system. Perhaps the destiny of Mars is not only to host life, but to become a springboard. The fleets of the future may depart from Martian shipyards, lighter in gravity, closer to asteroid resources. As Earth anchors civilization, Mars launches it, and the legacy of Mars will be not only itself, but the journeys it enables. Even if Mars never sends ships to stars, its role remains profound. The example of its transformation will teach humanity that barren is not forever, that silence can be broken. This lesson will echo in every corner of the galaxy we reach, and the memory of Mars will accompany us as we spread. So, the question of destiny expands. Is terraforming Mars the end or the beginning? The answer may be both. Mars is an achievement in itself, yet also a gateway, and the possibility it opens is larger than one world. Every voice that speaks of Mars also whispers of Earth. The planet we left behind will remain our first home, fragile and irreplaceable. Terraforming Mars does not absolve us of caring for Earth, and the wisdom of the project lies in remembering that lesson. When future Martians look at Earth through telescopes, they will see the origin of their kind, blue, radiant, a cradle across the void. The sight will stir pride and distance alike. They will know they are both of Earth and apart from it, and the identity of being human will stretch across planets. Perhaps the final stage of terraforming is not atmospheric but philosophical. The realization that life can spread across worlds transforms our understanding of purpose. We begin to see ourselves not as inhabitants of one planet, but as stewards of many, and the destiny of humanity expands to cosmic scale. Even beyond philosophy, the science continues. Ecosystems adjusting, climates balancing, technology adapting. The cycle of terraforming never truly ends, for life and planet keep shaping one another. As centuries pass, Mars may face new challenges, shifting orbits, magnetic drifts, resource limits, and the maintenance of balance will be the eternal task of civilization. So, Mars will remain alive as long as its people remain vigilant. The partnership between species and planet will endure beyond politics or eras. Life there will not be effortless, but it will be enduring. And the continuity of that endurance is the true success of terraforming. Every end is also a beginning, and the story of Mars is no exception. The planet that once stood as symbol of desolation will stand as symbol of hope. Its silence has been replaced with voices, its barrenness with growth, and the lesson it offers is that even the impossible can bend to patience. When we look to the stars, Mars will remind us that distance is not defeat, that harshness is not final, that life can carve meaning anywhere. The truth of terraforming is not in technology alone, but in perseverance. If we can turn Mars into a home, we can turn despair into possibility. And the belief that follows will carry us to the galaxies.